In this video, I'm going to show you how to calculate the slope of a line. The slope of a line is just the ratio of how much the line rises up to how much the line runs over to the right. To find how much the line rises up, we can look at the y-coordinates, y1 and y2. The amount the line rises up is just given by the difference, y2 minus y1. Similarly, to find the run of the line, we can look at the x-coordinates, x1 and x2. The amount the line runs over to the right is also just given by the difference, x2 minus x1. And the slope is usually denoted by the letter m. So this right here is our master formula for the slope. One thing to be careful about in this formula is that the order of subtraction matters. If you do y2 minus y1 on the top, then you have to do x2 minus x1 on the bottom. You can't flip it around and do, say, x1 minus x2. It has to be x2 minus x1. The 2's come first, minus the 1's. Let's do a concrete example with actual numbers for the points. To find the rise of this line, we need to look at the y-coordinates 5 and 9. The line rises from 5 to 9, so the rise is just the difference, 9 minus 5. Then to find the run, we look at the x-coordinates, 2 and 5. The line runs from 2 to 5, so the run is given by the difference 5 minus 2. And to double check ourselves, let's look, we've got 5, 9 here at the beginning, then minus 2, 5. So the order is okay. Now we can go ahead and compute this. 9 minus 5 is 4, and 5 minus 2 is 3. And that's our slope. M equals 4/3. Now what this slope really means is that every time we go over 1 unit to the right, we go up 4/3 of a unit. So if we go over 1 unit to the right, 1 unit here, we go up 4/3 unit. And if we do that again, over 1 unit, we go up another 4/3 unit. And if we do that one more time, over 1 unit, we go up 4/3 unit. Here's another example, which is just a little bit more challenging because we've got some negative numbers here. But the idea is still the same. To find the rise of the line, we have to look at the y-coordinates, 5 and -1. The line rises, or rather kind of falls from 5 to -1. So the rise is negative. It's going to be -1 minus 5. And then the run, we have to look to the x-coordinates, 1 and 3. And the line runs from 1 to 3, so it's the difference, 3 minus 1 is the run. And let's check that we have the order set up right. The point 3, -1, that comes first, good. And then the point 1, 5, that comes second, good. Okay, so now we can go ahead and do our subtraction. On top we have -6, and on the bottom we have 2. And the end result there, -6 divided by 2, is -3. So m equals -3. That's our slope. And how we interpret this in terms of the line is that whenever we go over 1 unit, we have to go down 3 units. The y decreases by 3. And if we do that twice, then we'll get to our second point on the line. Here's another example, which is a bit trickier still because this line is horizontal. It doesn't actually rise at all. So to calculate the slope, to calculate the rise, well, it doesn't rise at all, and we can also see that from looking at the y-coordinates. It rises from 2 to 2, so the rise is just the difference 2 minus 2, which will come out to 0. That makes sense. And then let's calculate the run. The run is more familiar to calculate here. We just look at the x-coordinates from -2 to 3, and it runs from -2 to 3, so the run is 3 minus -2. And we'll just check that we have our points in line here. 2, 3, or 3, 2 rather is here, and then -2, 2 is the second point. Great, so they're matched up. And we can go ahead and compute this. So we get 0 on top over 3 minus -2 is really 3 plus 2, which is 5. And so 0 divided by 5 is just 0 then. So the slope is 0. And what that means in terms of our graph is that every time we go over 1, we go up 0. So we just end up going over 1 a bunch of times to the other point. And that makes a whole lot of sense because the line is just flat. It's horizontal. It doesn't rise at all. Our last example is kind of similar, except instead of being horizontal, the line is vertical this time. So let's go ahead and compute the slope. To find the rise, we just look at the y-coordinates, 1 and 2. And to find the rise, we take the difference, 2 minus 1. And now to look at the run, this part is the more unusual part, because the line doesn't actually run at all. The x-coordinates are 3 and 3, so it just goes from 3 to 3. So our run is just the difference, 3 minus 3. That'll come out to 0, which makes sense because it doesn't run at all. Okay, so let's perform this computation. Let's check that our points are matched up. We've got 3, 2, 3, 2, and 3, 1, 3, 1. Great, we've got the right order. So yeah, we're good to go ahead. 2 minus 1 is 1, and 3 minus 3 is 0. And 1 over 0 is undefined. So our slope, m, is undefined. And what that means in terms of the graph is that it doesn't make sense to go over 1. We can't go over 1 in the line because the line is straight up. There aren't any points of the line that have an x-coordinate that's like 4. That's 1 more than 3. So we can't actually do the geometric interpretation of going over 1 and then up some amount. We just have to go straight up some amount. So the slope is not going to be defined in this case. In the future, we'll learn how to use the line's graph to tell whether its slope is positive, negative, 0, or undefined without even needing to perform the calculation.